Good morning, students. I am your business maths teacher. I hope you are all fine at home. In last class, we have studied, that is revised about the example sums. Today, we are going to revise the example and exercise in 1.1. The important concept we are going to revise today are minor of matrices, cofactor of matrices, adjoint of matrices and inverse of matrices. The first sum is related to example 1.1, how to evaluate the value of the determinants. That is, here in example 1.1, evaluate 2 4 minus 1 4. Here it is given 2 into 2 matrices. So in order to find or evaluate the determinants, we have to cross multiply the main diagonal. Here the main diagonals are 2 4. Okay, 2 4s are 8 minus, the minuses comes according to the formulas. Okay, after that one more minus is there, minus 1 into 4. Therefore minus 4 into minus becomes plus 4. 2 4s are 8 plus 4 equal to 12. So this is the method to find out or evaluate the value of the determinants for 2 into 2 matrices. So to evaluate the determinants of 3 or more, we define minus as well as cofactors. Okay, so if it is 2 into 2 matrices, it is very easy to find the determinants of the values by way of cross multiplying the main diagonal and subtract the off diagonals multiplication. Okay, this is how we have to find the value of the determinants. Okay, next we are going to find the value of the determinants of order 3 or more by way of finding the minor as well as cofactor of the determinants. Here minor is defined as, let A be a determinants of an order n. The minor of an arbitrary element A of ij is the determinant obtained by deleting the ith row and jth column. For example, if you are finding the value of the order, that is finding the value of the first row first column element first row and first column, means you have to delete the first row and first column. That is the meaning given here. By deleting the ith row and jth column, first row first column. If it is second row means second row, second column means second column is delimited. Okay, in which the element stands. The minor of an A of ij is denoted by m of ij. Okay, then now we are going to see about the cofactor. Okay, so cofactor is nothing but we are giving some sign to the concept minor. Okay, so that is the way we are finding the cofactor. Cofactor is a signed minor. Okay, cofactor is nothing but it is a signed minor. The cofactor A of ij is denoted by A of ij and is defined as A of ij into minus 1 power I plus j m of ij. That is, if it is first row first column means m11 means minus 1 power 1 plus 1. Okay, 1 plus 1 become 2, minus 1 square become plus 1. So if it is odd number means the power is odd number means it becomes minus. Okay, this is the way we have to find the cofactor. Example 1.2. Find the minor and cofactor of all the elements in the determinants 1, minus 2, 4, 3. Okay, so here it is given 2 into 2 matrices. Okay, so it is very easy to find the minor and cofactor for 2 into 2 matrices. The first element is 1. Okay, so the first element is in first row first column, therefore m11. Okay, opposite to that number, that is diagonal, is 1 3. Okay, so minor of 1 is 3. Likewise minor of 2 is, that is first row second column minus 2. Minor of minus 2 is opposite to that is 4. That is m12 is 4. Likewise minor of 4, that is first column second column first row, m21 equal to minus 2. Then minor of 3 m22, that is second column second row, it is 1. Okay, so this is the way we are finding the minor of 2 into 2 matrices. After finding this minors, we are giving the sign in order to find the cofactor. Here m11 equal to 3. Okay, then cofactor of 1 equal to 3 into minus 1 power. It is stands in the first row and first column, that is a11. Here take this a11, 1 plus 1 2, that is minus 1 power 2 becomes plus 1. Plus 1 into 3, 3. Okay, so m11 is nothing but the answer we have find already. So that is the value here. So we are finding the value of this by way of finding minor. Then we are going to find the cofactor of the matrices. So this is the way we have to find the value of the matrices. Okay, next we are going to see about the second element, that is cofactor of second element. Here the cofactor of second element is minus 2, that is a12 minus 1 power 1 plus 2, a12 first row second column, therefore 1 plus 2 3, minus 1 power 3 becomes minus 3, minus 1, that is minus 1 cube becomes minus 1, minus 1 into minor of minus 2 is 4, minus 1 into 4 become minus 4. Okay, then we are going to see about cofactor of 4, that is the second row first element. It stands in the second row first element, that is a21. a21 means 2 plus 1 3, that is minus 1 power 3, minus 1 power 3 means minus 1. So minus 1 into already minor of 4 is minus 2, minus 1 into minus 2 become plus 2. Then cofactor of 3, a22 minus 1 power 2 plus 2, it becomes plus 1, plus 1 into minor of m22 is, here already we find minor of m22 is 1, so 1 into plus 1, 1. Okay, this is the way we are finding the cofactor of 3. Next we are going to see about example 1.3. Find the minor and cofactor of each determinants 3, 1, 2, 2, 2, 5, 4, 1, 0. Listen, here the 3 into 3 matrices are given. Okay, first we have to find the minor of each and every element. Then we have to give sign for this minor in order to get the cofactor of the the element. Okay, listen, minor of 3, that is the first row first column, first element is 3, that is m11 is, m11 means nothing but you have to delete the first row first column. Here what is the first row? 3, 1, 2, that is deleted, you cancel that line, first row is cancelled. Then m11 means second row is 1, that is jth row is nothing but column, first column is deleted. Here the first column is 3, 2, 4. So if you delete the first row as well as first column, you are getting the value 2510. Listen here students, we have to find the value of m11 first row first column. Therefore delete the first row as well as the first column. Then the remaining element is 2510. After that you have to cross multiply this, that is 2 into 0, 0, 1 into 5 minus 5. We are getting minus 5 as answer of minor of 3, that is m11. Then first row second element, that is m12, minor of 1, first row second element, that is second column. So now you have to delete first row and second column. m12 is nothing but you have to delete first row 3, 1, 2, second column is 1, 2, 1. Okay, so if you delete these things, you are getting the remaining parts 2, 5, 4, 0. So if you cross multiply it, 4, 2, 0, 0, 2, 4, 5s are 20, you are getting minus 20. Then go to the minor of 2. Minor of 2 is nothing but first row third column. First row it is 2, third column is 2, 5, 0. So delete the first row 3, 1, 2 and delete the third column 2, 5, 0. The remaining element is 2, 2, 4, 1. Okay, this is the way you have to find the minor. Minor is nothing but, so if you are finding for minor 2, 1 means delete the second row and first column. 2, 2 means delete the second row and second column. 2 3 means delete the second row, third column. 3 1 means delete the delete the third row and first column. 3 2 means delete the third row and second column. 3 3 means delete the third row and third column. This is the way you have to delete. After deleting it, the 4 elements are remaining. There are 4 elements are there. So write those 4 elements. After writing this as minor, you have to cross multiply it in order to get the value of the minor M11, M12, M13, like that it going on. Okay, so this is the way we have to find the minor of each and every element. That is from first element 111, 112, 113. Likewise, you have to find for each and every element by way of deleting the row and column. That is, for example, if it is M23 means delete second row 2, 2 3. Okay, second row, third column. 3 1 means third row, first column. 3 2 means third row, second column. So you have to delete these rows. After that, you are getting the 4 elements, that is the remaining 4 elements. Write those 4 elements as a minor, and then you have to cross multiply it, then subtract it. You are getting the values like this. Okay, this is the way we are finding the minor of 3 into 3 matrices. Then we are going to see about the cofactor of 3, that is a cofactor of each and every element. Likewise, M11 means A11, A12, A13, A21, A22, A23, A31, A32, A33. Likewise, you have to find for each and every element. The number, there is no change in the number. For example, M11 is minus 5 means A11 also minus 5. Okay, M12 is minus 20. 20 means A22 also 20, but there is a change in the sign. Okay, so it is very easy to change the sign. For example, A11 means 1 plus 1, 2. 2 is a even number. Even number means there is no change in the minor. For example, M11 is minus 5. The A11 also minus 5, because 1 plus 1, A11 means 1 plus 1, 2. It is a even number means don't change the sign. If it is odd number means change the sign. It is the simple way of understanding it. Okay, for example, cofactor of A12 means 1 plus 2, 3. 3 is a odd number. So you have to change the sign of the minor M12. Here M12 is minus 20. Okay, minus 20. So minus 20 becomes plus 20 here. Okay, likewise, if it is a even number, there is no change in the cofactor. If it is odd number means, that is the summation of the cofactor is of odd number means, then it comes change in the sign. For example, the cofactor of A13, A1 plus 3 is 4. Okay, there is no change in the minors. That is M13. Already we find the M13. M13 is minus 6. Here there is no change. So minus 6 becomes minus 6. Okay, but A21 means 2 plus 1 is 3. 3 means it is an odd number. Odd number means there is a change in the sign. Here minus 2 become plus 2. Okay, so likewise you have to find for each and every element the cofactor. After finding the cofactor, you write it like a determinants form. Okay, in order to find the values. Okay, this is the way you have to find the value of the minor as well as cofactor. So why we are finding this minor as well as cofactor? So we are finding this minor as well as cofactor in order to find the adjoint. The reason for finding the adjoint is we have to find the inverse by using this adjoint. Okay, so if inverse is asked, you have to find minor, cofactor, adjoint. Afterwards, you apply the formula of inverse and find the value of the inverse. Okay, now we are going to see about the example 1.4, evaluate. Okay, example 1.4, evaluate. Here evaluate is nothing but find the value of the determinants. Okay, evaluate is nothing but we are finding the value of the determinants. Okay, wait students, the sum is about evaluate. Okay, so evaluate 124 minus 130 410. Okay, so if you find evaluate, the question is like this. You find the value of the first row or first column. Here the first row is 1 2 4. Okay, For first row only you are finding the minor. For example, you are finding the minor of 1 is first row, first column means delete the first row and first column. You are getting 3010, that is 1 into 3010. Then for second term minus is applied according to the formula, minus 2 into, that is second row, second column. Second element, first row, second element. So delete the first row as well as the second column. You are getting the remaining things minus 1, 0, 4, 0. Then plus 4 into first row, third column. 4 lies in the first row, third column. Therefore, first row and third column is deleted. You are getting first row is 1 to 4, that is deleted. Then third column is 4, 0, 0. That is also deleted. You are getting minus 1, 3, 4, 1. Afterwards, you cross multiply each and multiply by the element. You are getting the answer minus 52. This is the way you have to find the answer for evaluate. Okay. Then, so next it is properties. So already we finished these properties. Next we are going to see about the example 1.5. Show that x, y, z, 2x plus 2a, 2y plus 2b, 2z plus 2c, a, b, c equal to 0. So here we are using the properties. Okay. So according to the properties, we are using the properties here. According to the properties, the value of the determinants is unaltered when it rows and column. So this is the first properties, but we are using the property number 6. Okay. Listen. If each element in a row of a determinant is expressed as some or more terms, then determinants can be expressed as the sum of two or more determinants. Listen. If each element in a row or column of a determinant is expressed as sum of two or more terms, then the determinant can be expressed as sum of two or more determinants. That is, if here there are two sums are there, that is two terms are there in second row, 2x plus 2a, 2y plus 2b, 2z plus 2c. I am splitting these two terms into two determinants. Here x, y, z, 2x, 2y, 2z as a, b, c as one determinants. Next to the other determinants is x, y, z, 2a, 2b, 2c. That is, I am splitting these two into two determinants. One determinant contains x, y term, other determinants contains a, b, c term. Okay, in second row only. The first and third row there is no change. Okay, so there is no change in the first and third row, but in second row only I am splitting the determinant elements into two determinants. Okay, because two elements are there, therefore I am splitting into two determinants. Now see, 2xyz, second term also xyz. If two rows are having the same number, for example, if you take 2 as a common, the first row and second row is equal. In second determinants also x, y, z, a, b, c, the second row and third row are equal. Therefore, the value of the determinants is 0. If two rows or columns are equal, proportional, then the value of the determinants is 0. Property number 5. If any two rows of a determinants are proportional, then the value of the determinants is 0. So here we are applying two properties. One is fifth property and another one is sixth property. First we apply the sixth property in order to split the determinants into two parts. After that we are applying the fifth properties. Find the answer. The value of the determinants is 0. It is proved. Okay. Done. We are going to see about the 1.6. 1.6 x plus 1, x minus 1, x. So this is the sum given here, x plus 1, x minus 1, x. So now this is a minor because there are two rows and two columns. Okay, now cross multiply it, x into x, x square, x plus 1 into x minus 1, a plus b, a minus b. Apply the formula, a plus b, a minus b. Then it becomes x square minus 1. So x square minus x square, minus into minus become plus 1. So if you cancel it, you are getting 1. Okay. So this is the way you have to find the value example sums. the value of the answer is 1. Okay, x plus 1, x minus 1, x is cross multiply it, then you subtract the off diagonals multiplication. Now we are going to see about exercise 1.1. Find the minor and cofactor of the elements of the following determinants. 5, 20, 0, minus 1. Let A equal to 5, 20, 0, minus 1. Minor of 5 is opposite to that is minus 1. Minor of 20 is opposite to 20 is 0. Minor of 0 is opposite to 0 is 20. And minor of minus 1 is 5. So 5 minor of 5, that is first row first column M11. Minor of 20 means M12, first row second column. Minor of 0 is second row first column M21. And minor of minus 1 is M22, that is second row second column. Okay, so this is the way you are finding minor. So first minor of M11 is minus 1. Okay, 1 plus 1, 2. 2 is the even number. Therefore minus 1, there is no change in the cofactor for this. Cofactor of 5 is minus 1. Whereas the cofactor of 20 is 0. 0 becomes, there is no sign for the 0. Okay, so if it is plus or minus, it becomes 0 only. So 0. Then cofactor of minor of 0 is, that is M21. 21 means 2 plus 1, 3. That is A21. 3 means minus sign. So minor of 0 is 20, whereas cofactor of 0 is minus 20. That is, you are changing the sign of the cofactor, because A21 means 2 plus 1, 3. So 3 means it is a odd number. Minus 1 power 3 become minus 1. Minus 1 into M21 is 20. So minus 1 into 20 becomes minus 20. Then cofactor of 5, that is A11. A22. A22 means 2 plus 2, 4. That is minus 1 power 4 becomes plus 1. Plus 1 into M22 is 5. 1 into 5, 5. So this is the way you are finding the cofactor and the minor of the element. Okay. Next we are going to see about the next sum here. Next we are going to see the same model, that is here also we are finding the minor and cofactor of 3 into 3 matrices. Okay, so 3 into 3 matrices. Then we are going to see about the evaluate sum, second sum. Evaluate. Okay, evaluate 3 minus 2, 4, 2, 0, 1, 1, 2, 3. Okay, so this is the sum. Here let A equal to 3 minus 2, 4, 2, 0, 1, 1, 2, 3. Now expanding along with the R1. Evaluate means you expand the first row and find the value. That is the answer for this question. Okay, so evaluate means expanding along R1 we get. R1 is 3 minus 2, 4. Right, 3 minus 2, 4. Okay, for the element 3, what is the minor for element 3? 3 lies in the first row first column, means delete the first row first column. You are getting 0, 1, 2, 3. That is 3 into 0, 1, 2, 3. Okay, next one minus, here also minus sign is there. That is in first row second column minus 2 is there. Therefore minus of minus 2 into first row second column is cancelled. You are getting 2, 1, 1, 3. That is minus 2 into 2, 1, 1, 3 plus 4 into, I am finding the determinants of A. Okay, so plus 4 into, 4 lies in the first row third column. So first row third column is deleted. You are getting 2, 0, 1, 2. Now I am multiplying, cross multiplication. 0 into 3, 0. 2 into 1, minus 2. Plus 2 into 2 3s are 6. Minus 1 1 is 1. Plus 4 into, cross multiply the main diagonal. 4 2 2s are 4. Minus 1 0 0. So if you simplifying it, you are getting the answer minus 6 plus 10 plus 16 equal to 20. The value of the determinants A is 20. Okay, this is the way you have find the value of the determinants. Okay, evaluate means you have to expand the first row. Okay, if you expand the first row and multiply its minor, then you are getting the value 20. Okay, so if you want to find the inverse means first you have to find determinants of A. So therefore listen the sum carefully how to find the value of the determinants A. Then third sum, solve. Here also we are doing the same, that is expanding the R1, but here in this sum the value of the determinants is 0. It is given that the value of the determinants is 0. By using this condition we have to find the value of the x. Okay, that is the question here. Okay, so solve 2x3 416 127 equal to 0. Expanding along R1 we get 2 into, that is here the 2 lies in the first row first column. Delete the first row first column. First row is 2x3, delete it, cancel it. Then first column is 241, cancel that also. Remaining element is 1627, that is 2 into 1627 minus second element is x into, delete the first row second column, you are getting the remaining things 4617 plus 3 into 41, that is the first row, third column is deleted, 4112 equal to 0. 0 is given in the question. The determinants of the value of the determinants is equal to 0. Okay, now cross multiply it. 2 into 1 7 is 7 minus 2 6 are 12 minus of x into 4 7s are 28 minus 6 plus 3 into 4 2s are 8 minus 1 into 1 1 equal to 0. So if you simplify these things you are getting minus 10 minus 22x plus 21 equal to 0. Therefore 22x equal to 11, x equal to 11 by 22. If you cancel it, the value of the x equal to 1 by 2. Okay, there are two methods here. One method is we are finding the value of the determinants, that is delta A, that is determinants A. The other method is the value of the determinant is 0, means you have to find the value of the x. Sometimes instead of x they may give A, lambda, anything. Okay, so you can solve, you can find the value of this x or lambda, anything given, means the way is expand the R1, we get some minor, multiply it and getting the values. Okay, after changing the solving the question. Okay, so this is the way we are finding the question. Today in morning session we revise the topic like cofactor, how to find the minor and how to find the cofactor, as well as how to calculate the evaluate the value of the determinants. That is here we find the value of the determinants by way of expanding the row. That is I am expanding the row in order to find the value of the determinants. Okay, so this is the second and third question. We are using this rule. Expanding R1 we get the value of the determinants, and third questions expanding R1 we are finding the value of the x. Okay, after watching these videos, do all the sums, that is all the sums means already you finished the example sums as revision, and do the assignment following this link. Okay, so revise it in order to score more marks. In these topics that is exercise 1.1 and exercise 1.2 is enough to score full marks in your that is monthly test. Okay, so that I am revising exercise 1.2 in 1.1 in morning session and 1.2 and 2 in afternoon section. After watching this, do the assignment, students. Thank you.